And welcome back. So, our first task is to build ourselves a sparkler rocket. In fact, you're going to build two. You're going to work in pairs or threes if you like, so there's small groups. I get to watch you working together, which is important for me. Um, and you also get to collaborate and learn to work with each other. And we'll see how we go about doing some science. That's a bit of fun. So you'll find that our first folder inside our general science class is called Rocket Investigation. As you can see, I've got a few variations on this task. Keep playing around changing things. So we're doing this one. You'll only see one. This is my view, obviously, so I can see all three. You'll see this one that I've opened up to you guys. And that's where you need to go to find your this lesson. Hopefully you've already logged into Style. If you haven't, log into Style. You've got a class code and it's on sector for you as well. And then we get into this task. So the first thing is to define the task. And I've actually done the definition part for you. So your task is to create a sparkler rocket. That is a rocket that is able to rise a minimum of 10 centimeters using just sparklers to power it. I will supply a packet of 12 sparklers for each group, gaffer tape, cardboard, scissors. You might think of other things you need and you can request those and we'll make sure you've got them. You need to think about how you're going to launch. Will it stand on legs? Will it have a little hook system on the side that we can put over a bit of wire and find a launching pad? So you need to think about launching. So when you're designing this, you often get caught up in trying to make the rocket and forget about, what do I need to think about for launching purposes? So that's your definition. That's what you've got to try and build. You're going to build two. You're going to build one, test it, and then build a second one, hoping to improve. Okay. So first step, do some brainstorming. Get together in your groups of 2 and 3. You can spread around the room and find yourself some space and start brainstorming. You'll see these are all style screenshots. There's a space here for you to put your ideas up. So part of the assessment of the task is me seeing you suggesting ideas about how it's going to work. Remember, when you brainstorm, you just dump ideas. Be wild, be crazy. Get stuff in there. And then you can sort it out later and work out which bits you want to use. But the first thing is actually get the juices going and just dump ideas. No wrong answers. You try and work out how to launch a rocket with 12 sparklers. Then you got to do a bit of research. You do need to think about, okay, rockets exist. People have been using rockets for a while. How did they design rockets and make them work? What do they need to overcome? Okay, so then again, you're going to have to upload stuff you find. You're going to find lots of videos. There's lots of videos on YouTube of people building and launching sparkler rockets. Might be worth a visit. Obviously, there's also stuff about rockets themselves. So thinking about how that works. Check out some of those videos too about how they've gone about setting up for launch. How have they built in some facilities to make that launch? Yeah, think about that. It's a really important part of it. And just a little head start, because I'm not there and I normally talk about this and draw things on the board for you. The most important idea here is Newton's third law. It says that for every force, there is an equal and opposite force. So in this diagram here, you can see this force coming down is a thrust force from the exploding fuel. So that's downward force, and that's causing the rocket to go in the other way. That's what you want. As you can see from this diagram, there are no flames coming out sideways at the top. Because if I had flames coming out the top, that'd try and push the rocket that way. If I had flames coming out that side, that'd push the rocket that way. Oops, didn't mean to do that. Back up there. So you really want all your stuff coming out the bottom. That's a really important feature. Newton had a couple other laws that come in handy, so you might want to check out Newton's 3 laws. We'll see that in class after we've done our sparkler rockets. Also think about the forces. Gravity is trying to pull this thing down. It also has an enormous mass, which is what we call inertia, so there's a force of inertia to overcome. It's also got a whole lot of drag. There's air resistance, so there's friction against the air that has to be overcome. So you can see it's a pretty streamlined looking device. But it's pretty heavy too. This one's got an old Challenger attached to it, space shuttle. They've got a lot of drag in this, but they've streamlined all those opportunities as much as they can to make it possible to launch it. It's also carrying an enormous amount of fuel and producing a lot of heat and energy here. So how are we going to get some motion to overcome all these other forces? So think streamline. Think how you can make yours as streamlined as possible and as light as possible. So reduce the amount of inertia. Can't do much about gravity, it just exists. So you design. So in today's class, I'm hoping you get through the design stage because we'll start building tomorrow. So what are you going to use? Think about why you're using bits and pieces. Think about how you might use stuff to overcome some of these problems. Think about not using too much to seal it up. You got to seal up the rocket so that the fuel all burns down the bottom. But you don't want to use too much gear because you make it too heavy. And you've only got 12 sparklers, so they're going to produce enough energy to take a large mass up. They need to be taking a light mass. There's some really big design issues involved here. And don't forget to design how you're going to launch it. What's it going to stand? And then tomorrow we'll start building. We'll get you creating on Thursday. So we create, and hopefully Friday's class will go off and explode some rockets. Weather permitting, of course, there's always a problem. If we get a good day, not too much wind, wind's the real issue. I mean, it's pouring with rain, we don't want to do it, but there's also the wind's the problem for us lighting the sparklers and controlling where the rockets go. But hopefully we'll test on Friday. And then the next week, you get a chance to rebuild. Okay, so what went wrong? What can I do better the second time? And build a second one, at which point you will, test that one too. I'm going to put a second test in, sorry. So you need to build a new one, we'll test again. So next week we'll do a second firing, and hopefully that will do better. And then, of course, you need to produce a little report and share what you've learned. So you'll find on each of these stages, there's space here to add stuff. I'm encouraging you to bring your phones with you or bring a camera so you can record stuff. So take photographs of your design and building, and then take little short films or photographs of your rocket as it launches. Really useful for showing what you've learned, and there's spaces to upload those. And then we've got to think about assessment. This is my original assessment rubric, and you'll find that as part of the style worksheet, which gives you a fairly good idea of the things you've got to think about. You've got to be defining, researching, designing. So these are all things you're going to get marked on. Creating, obviously the building part, and testing and evaluate. Test and evaluate. So it's not just a matter of firing. How do I get good data from my firing? So think about that. You've got to get some data. And then, of course, you're going to do a presentation, and you're working in teams, so I'm watching you collaborate, so I make a little idea about collaboration. And, of course, we're going NYP this year, and this is a piece of formative assessment already for general science in the NYP, and so I've had to apply their rubric. And so this is also a rubric that's been designed using the style that NYP prefer. I must prefer mine, but anyway, you shouldn't say that. I've got to use these. And you score between 0 and 8 points towards your achievement of this particular criteria. Again, you'll find this is all the same stuff what we're doing in class with the other rubric, but just so you see how I'm going to have to mark it for official marking. This one will appear on sector. Okay, I'll shut up now that you get some work done. So do a bit of research, get your brainstorming going, get that design worked out, and then tomorrow we can get into building. And I'll see you in class tomorrow. I'll finally appear. I'll see you then. Have fun.